All right, it's 1 o'clock. Good afternoon, everyone. How's everyone doing today? Everybody good? Okay, good. So what I want to do today, first off, I just want to remind everybody that next Tuesday you have your first exam and your second homework due. So if you look on our course syllabus, scroll down to Tuesday 9/22, that's exam number 1, and you have your second homework here that's due. How many people have started the homework so far?
Hi, Professor. I started the homework, but I have a question.
Sure, go ahead.
So on the second question, I'm not sure if I'm right, but I got 0.151.
Are you talking this second question here? Is
Yeah,
that what
for
you
the
said?
weighted
That
mean.
does not sound right. So what you need to do is, I can't write on this.
Don't you have to times them and then
Yeah.
add all of them together, and that's how you get your answer?
Well, hold on.
Okay.
So the first thing you need to do is you need to multiply everything, and then you'll get a new column here. You'll sum up all those values, okay? And then you need to divide it by something, okay? You need to divide it by the sum of the weights. So it turned out that our weighting variable is this. So you need to take whatever values you get here and divide by the sum of all these numbers here.
Okay, so I multiply, for example, 55 times 12, and that's gonna give me a new column.
Yes.
And, what do I do with that column then?
So the weighted mean, the formula tells you to sum up all the values here, add them up.
Okay, and then I divide it by the population in millions.
You divide it by the sum of the population.
Okay, I'll try to do it. Otherwise, I'll email you.
Yeah, you should get a value like 54 point something, I believe is the weighted mean.
Okay, thank you.
Yeah. Does anybody have any other homework questions while I got the homework loaded up?
Yes, I do actually.
Sure.
For the question relating to the linear correlation coefficient, I just wanted to know if it was okay for us to use the calculator.
Absolutely.
Get R, or do we need to actually show the working for R?
Calculator. That's all you need to do is a calculator.
All right, thank you.
I have a question with the calculator.
Yeah.
So I forgot the name of it. Starts with a D.
Diagnostics on.
Yeah. I don't know what to do after that because I have the TI-84 plus.
Yeah, which is this, right?
Yeah, but it's not letting me, like, if I press like enter, it just goes like back. So it's not letting me get to that other settings to get to.
So you can also, with this one here, let me see. Not exactly sure. Yeah, you have to do the diagnostics on. I'm going to redo that all today so you can see it and just follow along. And then if it's not working at the end of class today, we can fool around with it. You know, I'll stay after class and try to work with you on it. Okay.
Okay, thank you.
Yeah. Any other questions, anybody? All right. So let me just talk real briefly about the exam before we go back into the lecture. Okay. The best way to study for the exam is to look at the first two homeworks. Okay, because all these first two homeworks these are just actually old exam questions that I just pulled. So these are the type of questions that I will be asking you. Okay. However, these type of questions were how I would ask during a class that met, in person when I would give them a paper exam. So let me just talk real briefly about the exam format, okay? And then I'm gonna do like a little review at the end of class for you. All right, so on exam day, what'll happen is you'll log into the classroom and I have this tab here called exams. when you click on here, exam number 1 will be posted here, okay? I'll actually start class on exam day, showing you how to access the exam and how you input everything into it, okay? So don't like just jump right into the exam until we actually start class that day, okay? So your questions are all gonna be a mix of like multiple choice, numerical input, like it'll say, hey, you know, what is the average of this data set? And you will have to type in your number. And then there'll be some questions that you have to write answers in, and that I will go back and manually grade later on. Okay. So as I said at the start of the exam, I'll open up exam, show you how to input solutions. And then I'll also keep the exam open for an extra 15 minutes after class should you run late, but you really shouldn't, but just in case. And I'll give you a lot of time warnings and stuff like that. All right. So that's
I have a question.
Yeah.
Sorry.
That's okay.
How are we supposed to do the exam? So we're supposed to open up the exam on one page and the Zoom class on the other, so
Yeah,
people watch us?
So initially I wanted everyone to be on camera just because of just cheating concerns, things like that. But I've gotten a lot of pushback on that. So it's just going to be an honor system. So you'll have Zoom loaded up just to watch me initially do show you how to do the exam and stuff like that. Also, like a lot of times there'll be a question during an exam, and normally like during a class, someone would raise their hand and say something and I'd walk over. Well, we can't do that with this. So you won't have to turn your camera on, but I would like you to just be present in Zoom.
Okay, thank you.
Yeah. So the exams are all open notes, but you don't have to. I do want to stress though, like when you open up an exam, you just like can't click out of it and go back to course content and stuff like that. So when you have the exam open, have all your notes and stuff already open elsewhere or printed out so you can access it. Like just don't try to open an exam and then leave it. Okay. Once you open an exam, you have to stay in it. I'm sorry, I won't post the solutions right before the exam. Just because it's a graded homework. But I'm more than happy to, if you message me your homework before during my office hours, I'll look it over and tell you what I think.
Sorry again.
I have
Okay.
One at a time.
Okay. She could go first. It's fine.
Okay.
my question is for the written part. Do we have to go to Word, or will it be like?
Nope. So what'll happen is when you take the exam, like a little text box like this will open up.
Oh, okay.
And you'll just have to write in like your solution. I think this is the answer. Here is some work. Like for example, like one of the questions I'm going to ask you to write your answer in is the Z-score question on the exam. So like you'll have to just say something like the Z-score for the man, let's just say it's comparing a man to a woman, is 2.3. The Z-score, sorry, my typing here is bad, for the woman is 1.45. Whoever is doing better relatively. That's what you'd have to type into the text box. Does that make sense?
Yeah, thank you.
Sure. Someone else had a question?
Yeah, I had a question.
Yeah.
So just to clarify, if we have a question, we just unmute ourselves and ask it, or do you want us to text it in the chat? Because I don't want to distract other people if we're.
That is a fantastic question. Why don't you put it in the chat first, and then if it requires to turn your audio on, it requires to turn your audio on.
Okay.
All right.
Thank you.
People can also turn off their mic, like during the exam, if they don't have any questions. No, you can just mute your computer.
Okay,
Yeah,
thank you.
no problem. Yeah, I'm going to do a little bit of review at the end of class, depending on how much time we have.
Professor, will be you in the time class the whole time or not?
Yes. First to answer the question in the chat, yes, you can message me privately with questions. That's totally fine. And yep, so you will have the entire 2 hours to do the exam. Okay, I'm probably going to have the exam open up a little early before class in case anyone just wants to open it up and look through it. I wouldn't do that. I would wait to class. But then I will also leave the exam open up for about 15 minutes after class in case people run over. Any other questions? Okay. So you can have, I would have all the notes printed out that we've taken in this class, all the PowerPoints. I would have those all handy. You can have them opened up on your computer elsewhere if you don't have a printer, stuff like that. You know, I think this is the easiest of the 4 exams, so I get good vibes that everyone will do well. You know, no stress, okay? Don't stress. I know that's easier said than done. All right. Stress in the real world is when your child wakes up at 2 in the morning screaming and you have a hard time going back to sleep. Stats exam, piece of cake. You guys got this. Okay. No, I got okay sleep. I'm just a complainer, as my wife likes to point out. I'm just complaining. I got fine sleep last night. Actually, the screaming child doesn't bother me anymore. I'm just used to it. That makes me sound like a terrible father. I'm not. I'm an excellent father. But anyways, let's just get to let's get to statistics. Okay. So I will I'll go back and do a review of some of the questions, some of the topics from earlier on in the class. But actually what I want to do is I want to pick up the lecture where we were last time, okay? So if you remember last class, I think this is as far as we got. I had this set of data here. If you remember, it was about hours of study and exam scores that people, from a random sample of students, correct? And I showed you guys how to use this formula here last class to find the regression line. Does that ring a bell? Okay. All right, so what I want to do here real quick is I want everyone to take out their calculator. And what I'm going to do is I'm going to, if you have this data plugged in and the settings already done, you don't have to do anything. But I am going to reset my calculator and start from scratch just so everyone can see, okay? Because a lot of times when you have calculator issues in this class, just resetting the calculator fixes it. So I'm gonna hit second function, memory, and then it's options 7, 1, 2. And what you have to do here for regression is you have to turn this option called diagnostics on. So I'm gonna go second function down to catalog here. And I'm gonna hit the X inverse button. I'm gonna scroll down till I see diagnostics on. I'm just gonna hit enter and I'm good, okay? Next thing I wanna do is I wanna input this data into my calculator, okay? So I'm gonna hit the stat button. I'm gonna scroll over to calc. Oh, geez, I'm getting ahead of myself. Under stat button, under number 1, I'm gonna edit the list. And this is important. To plug the data into your calculator for L1, you always need to put the explanatory variable. So for this problem, we said that was hours of study. Like this. And then the response variable always goes in L2, which was the exam scores. Okay. So the next thing I'm going to do is I'm just going to look at the scatter plot again so we can just see how that's done. So I have to turn on my stat plot because I turned it off. So I'm going to hit second function stat plot. And I'm going to say plot 1 and need to change it to being on. And I need to make sure this one is selected. Okay. Whenever you input new data in your calculator, you're going to hit zoom and you're going to zoom stat. Okay, like this. All right, so what we saw here is that this looks like it's a linear relationship. So then what we did next was we calculated the value of R, which was the linear correlation coefficient. So to do that, I'm going to hit the stat button on my calculator. Now I'm going to scroll over to calc. And I want option number 4 here, LinReg. Okay, option number 4. So if you have a TI-83, you just hit enter again at this point. With the TI-84, you just scroll down to calculate, and you see something like this, right? So the value of R, the linear correlation coefficient, is right here. It's 0.9943, right, which is really close to 1. So it's telling us, hey, look, there's probably a positive linear relationship between the variables. Okay. Then we wanted to model this relationship. Okay. And to model the relationship, we use what's called least squares regression, or find the least squares regression line. Right. To going back, you got lost where? Talking about what?
Fine, you can keep going. I'm gonna rewatch the recording after.
I also, I'm gonna say this, okay? It's hard to go back. Listen to me, everybody. It's hard to go back to pick up in the middle of an example, but I have, and I see everything in the chat. I have 2 more examples, okay, where we're just going to work it just from start to finish of this, okay? So don't stress too much jumping into the middle of this example. Just kind of listen to what I'm doing for now, okay?
Okay. The thing is, I get confused when it's about using the calculator because like putting the data numbers in.
Okay.
But it's okay.
Yeah, listen to me, the best way that I think you can study for the exam is to take these problems that I do in class, cover up the answers and try to replicate them. So you'll get a lot of practice work that way, knowing what the answer, knowing that you can look back and get the right answer.
Okay, thank you.
Okay. All right. So this was the least squares regression line we found last class. Okay. What we were trying to do, we were trying to predict people's exam scores if you tell them the hours of study. Okay. So we said the predicted exam score is equal to the slope, which we found by hand was 5.0333 times X, which is the hours of study, plus this 45.0835. Okay. The intercept. All right, so now that I have this model, let's answer some questions so you can see how we're going to use this, okay? All right, so I'm just going to rewrite it here, okay? My equation was y hat is equal to 5.0333x plus 45.0835, okay? So the first question says, now let's plot the line in our calculator and see if it fits the data well. Okay, so what I want to do is I want to put this line into my calculator. So if you still have all this plugged into your calculator, you can follow along. If not, just watch me, and then don't worry, we're going to do another example in a little bit. Okay, so if I want to plot a line into my calculator, okay, I'm going to hit this y equals button right here, right? And you'll notice it says y1 is equal to. All right, so what I'm gonna do is I'm gonna have to type this equation in. So it's 5.0333. And then to put the X in your calculator, there's this little button right here, okay? Right where my mouse is. And you see it says X, comma, T, comma, theta, comma, N. This is the variable button. You're gonna hit this. And then it's plus 45.0835, okay? Then you're gonna hit enter. Now what you're gonna do on your calculator, if you have this plugged in, is you're gonna hit the graph button, okay? So I'm gonna hit the graph button and watch what happens on my calculator. I see this, okay? And just out of curiosity, was anybody able to follow along with me and get that as well? All right, and don't stress if you didn't. We're gonna get to practice this 2 more times, so don't stress. We're gonna get to do it 2 more times, okay? But let's just move forward with this example. Okay?
How do I get my graph to be zoomed out again?
So it hits zoom, and you wanna find this thing called zoom stat. Okay,
I did the same, but it's still showing.
so everybody, if you're not seeing that, what you have to do to make sure that you see,
I got it.
yep, if you're still not seeing it, hit second function stat plot and make sure it says plot 1 ... on. Okay, make sure it says plot 1 ... on. That's important. All right, and then we're gonna get a chance to redo this again. Okay, so don't stress. All right, if you're not getting this exact same thing for right now. Okay, we'll stress more if you don't have it on the next example. Okay, so here's the question. All right, does this line that I drew through the data fit the data well? What do you think? Yeah, like absolutely it fits it well. It doesn't like, you can't fit it perfectly because the dots don't line up in a perfect straight line, but it really, really fits the data well, okay? Really fits the data well. So going back, yes, the line fits the data well. Okay, so now if you look back at our data value, our data table, okay, there's no data point for someone who studies for 5 hours, okay? So suppose you're like, you know what, I'm gonna study for 5 hours the night before, okay? What do I think my grade's gonna be? Well, obviously it's gonna be somewhere between this 65 and 78, but what will it be exactly? Okay, so let's go through, yeah, you are correct, but let me just go through this, okay? So for this type of stuff, you're gonna use this equation. Okay, you're gonna use your regression equation. All right, remember, y hat here gives the estimated or predicted exam score. And what does x give us? Okay, what does x represent? Well, we're gonna do this by hand, okay, to answer your question. Yeah, this is the hours of study. All right, do I tell you how many hours someone's gonna study for? Yeah. So I'm telling you're given that x is equal to 5. Okay, so what are you going to do with this value of 5? You're going to plug it in for x in your calculator, yeah, or into your equation, excuse me. So my predicted or estimated exam score is 5.0333 times 5 plus 45.0835. And you're absolutely right. If you plug this into your calculator, you're going to get y hat is going to be equal to that value, 70.25. So what we're saying here is we estimate an exam score of 70.25 for someone who studies 5 hours. okay? Make sense? All right, let's try it again. Okay, so let's use your least squares regression line. Y hat is equal to 5.0333x plus 45.0835. To estimate an exam score for someone who, like, let's say spends 10 hours this weekend studying. Okay, so someone's going to study for 10 hours. What do I do here? What do you guys think? Yeah, same thing. I'm telling you, you're given that x is equal to what? Yeah, someone's going to study for 10 hours. Okay, so you're going to take that and just plug it in for x. All right. And when you do that, if you plug this in your calculator, just to save some time, I'm going to quickly do it for us. You get 95.4165. Yep. So yeah, if you look back, like, you know, so we don't have a value for 10. So if someone's going to study for 10 hours, they're going to score really well on the exam. Okay. So I guess the whole point of this is study for Tuesday for the exam. Look over all the problems we've been doing. Okay. All right, so let's look at the next question. Find the residual when x is equal to 4. Okay, so, you know, what the heck was a residual? If you look back in our notes, okay, the residual, or what I called an error, okay, because remember I said this line is the line that minimizes the error. So let's find an error, okay? So the residual is the following formula. It's y observed minus y predicted. So the residual is equal to the error, and it's equal to the y observed minus the y predicted. Okay. So the y observed is the actual y value, okay? Minus the y predicted is this y hat here. Okay, so how do I find the actual y value when x is equal to 4? What I would do is I would go back to my table of data. So for somebody who studies for 4 hours, okay, what exam score do they get?
65.
Yeah, okay, so that's my y observed. Okay, this y predicted is what the model says the student will get. Okay, so how could I find what the model says the student will get if they study for 4 hours? Yeah, exactly. Yeah, you just plug it into the formula. See what the formula says the student should get. So y hat is equal to 5.0333. Now I'm saying 4 plus 45.0835. If you plug this into your calculator, I'm going to do this quickly in my head. Carry the 1. I think you get 65.2167. Okay. That was a joke. I actually just have it written down in front of me. Okay, I didn't do this in my head. Okay, but this, I know, you're going to hear that joke almost every day for the rest of the semester. I'm sorry. I think it's hilarious.
Professor, did you multiply that 5 times 0.033 times 4?
Yes, like in your calculator, you just go 5.0 or 5, sorry, 5.0333 times 4 plus 45.0835. That's how you got that. So now you just figure out the subtraction here, and you end up getting minus 0.2167. And that's the error. So the model was off a little bit, okay? The actual student who studied 4 hours got a 65, but the model said the student would get a 65.2167. So it was just a little error. Okay? Make a little sense, at least how we'll use these equations?
Professor,
Yeah.
how did you get a 65?
This 65 right here?
Yep.
Yep. So do you notice where it says x is equal to 4?
Yep.
You scroll back here.
Mm-hmm.
You see where 4 is on the hours of study?
Mm-hmm.
That's
Okay.
got it?
Yep. Yep. I got it now.
Okay. All right. So, yeah, but there's something wrong with my calculator that doesn't match. That means you inputted the data wrong into your calculator. That's I don't mean to be rude. That's like a user error, right? So like, if your data is not perfectly lined up, you just made an error inputting it. And don't worry, we're going to do another example next where you'll get a chance to input data again. Nope, the residual is the error. It's the same thing, like they're synonymous. Like like my name is Matt, but you can also call me Matthew. It's the two names for the same thing. So this is the answer. This is the residual. Okay. That's okay. Yeah, no problem, no problem. Yes, there will be a question like this on the exam. Yeah, I'll ask you to calculate an error, a residual. Okay. And don't worry, we're going to use our calculator next. We'll do some more examples. I can feel even though we're virtual, it's palpable, the stress perhaps, but don't worry, we're going to get this. All right, so we have this equation, okay? All right, this is our regression equation. So there's two parts to the regression equation. There's the slope and there's the intercept, okay? So how you interpret the slope, like what does this slope mean for the problem, okay? A slope is a rate of change, okay? That's what we learned in algebra, what a slope is. It's a rate of change. And so this is the actual interpretation, but let me just give you the algebra interpretation, okay? A slope of positive 5.0333 means when x increases by 1. So when you increase the value of x by 1, y increases by that slope. Okay? Yes. Yep, for that problem. Yes, the regression equation never changes. Okay. So in the context of our problem, X is the hours of study. Okay. So whenever a person studies for 1 additional hour, right, an additional 1 hour of study, what this means is their exam score is going to increase, because that's why exam score by this many points. We also say this is on average. Okay. Because, some students will study for an additional hour and they'll get, they'll get more benefit than another student. So this is just on average of all the students, okay? Interpreting the Y-intercept is a little bit different, okay? All right, so the Y-intercept for this regression line we saw was this number here. The interpretation of the Y-intercept, you need to ask yourself both these questions, okay? Is a value of 0 a reasonable value for the explanatory variable, which are hours of study? Meaning, can you have a student who studies for 0 hours? Does that make sense? Can some student not study at all for an exam? Yeah, it makes sense, right? Students cannot study. Yes. Okay, you can have that. And then the next thing you have to do is you have to look back at your data and say, do we have any values of X that were close to 0? Yeah, we sure do, right? Like this value 1 is really close to 0. So we have original data that's close to 0. Okay. So yes, if you have both of these answers, okay, then it's very, very reasonable, okay? All right, to interpret the Y-intercept. We'll do an example where you'll see it's not reasonable to interpret, but if you answer both these, yes, it's reasonable. What we can say then is somebody who studies for 0 hours, okay, we predict their exam score to be this, the Y-intercept. Okay, so study. For this, one last thing before we move on to a second example, okay? If the least squares regression line is used to make predictions of values of the explanatory variable that are much larger or much smaller than observed values, we say the researcher is working outside the scope of the model, okay? All right, so we're never gonna use this least squares regression line to make predictions outside the scope of the model, just because you can't be sure that linear relation continues to exist. So what I mean by that, if you look at our hours of study, okay, we have values like 1, 2, 3, 4, 6, 7, 8, and 9, okay? You wouldn't use this regression equation for somebody who studies for 40 hours, okay? Because that's just so far away from observed values, okay? And honestly, what would probably happen is after a certain point, all right, the marginal rate of return of studying diminishes. So you'd study initially, you'd see a linear progression in your knowledge or your score of your exam, but then after a while, you know, studying an additional hour won't give you any benefit for your exam score, okay? So we're only gonna use this to make predictions close to observed values, okay? All right, what do you say we just do a different example now, okay? Start from scratch, not hop into the middle, okay? Sound good? Okay. Lit, okay. All right. So what we have here, we have this example. And this is, I do this example every year. It's about scuba diving, okay? Has anyone just out of curiosity ever been scuba diving? It's fun. If you ever get a chance, you should do it. Yeah, good. One person have. I've been scuba diving once in my life. It was overseas, so it was really fun. All they did was they threw the tank on my back, put the nozzle in my mouth, and pushed me overboard. Okay, I'm sure it'd be a very different experience in the United States. Okay. But anyways, the following table here shows the max dive time in minutes, right here, max dive times based on the depth of a scuba diver, okay? Cave diving sounds fun. But anyways, so here's what you're noticing, just looking at this. As you increase the depth underwater, okay? What do you think happens? What does it look like happens to your max dive time? As depth increases, what happens to max dive time? So yep, as depth increases, max dive time decreases. Yep, because it's falling. All right. So the first thing here, you have two. We want to now do this regression correlation stuff for these two variables. So the first thing you have to figure out is which is the response variable and which is the explanatory variable. Okay. So the response variable is the Y, and the explanatory is the X variable, okay? So you have to ask yourself this. Does max dive time explain the depth the person's at, or does the depth the person's at explain the max dive time? So which one do you think is the X here? Yeah, I agree. Okay, so that's telling me this is my X right here, which means that my max dive time is my response variable, my Y. Okay, so the next thing we're going to do is we're going to create the scatter plot. We're going to use our calculator to do this. All right, so the good news is we're now going to start from scratch. All right, first thing we're going to do is you're going to clear out the previous example. So you're going to go into the Y equals button. You're going to clear this line out if you had it. You're going to clear it and hit enter. Always hit clear, clear. Next, I'm going to go into my stat button. And under number 1, I'm going to edit the list. I'm going to hit enter. And what you have to do here is you have to go to the top of each list. Do not, I don't know how many times I say this, do not hit delete. You hit clear, enter. Scroll over, go to the top of L1, you hit clear, enter. Okay, the next thing you're going to do, all right, you're going to go to this 20, and you're going to start putting in these values, 20, 30, 40, 50, 60. Okay, so under L1, you're going to put your X variable. Now under L2, you're going to put your max dive times, which was 100, 95, 91, 83, and 70. Okay, so as you put in the data, make sure they're perfectly lined up. Okay. Now what you're going to do, you're just going to hit zoom. And what do I want to look for here? Yeah, zoom stat. Okay. I'm not sure if it's option number 9 actually on the TI-83, so you might have to scroll down. But here on the TI-84, it's number 9. And how many people see this when they plug it in?
I do.
Okay. Good, 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 good. Okay, so we created the scatter plot. Awesome. The next question says comment on the relationship. So this is what the scatter plot roughly looked like. Something like this. Madeline, I'm just curious, when you look at your calculator, what does it say there? If you don't see that. You can turn your mic on and talk. Makes it easier.
Repeat this step.
I'm sorry, I can't hear you.
Can you just repeat the step, like how you got that?
Yep, did you hit zoom? Did you plug the data in?
Yes.
Okay, hit zoom, and then you're gonna scroll down on your calculator until you see something called zoom stat.
Yes.
And when you hit enter, you don't see this?
No. It's blank.
Okay, go second function, and then stat plot. Does it say plot 1 ... on?
Wait, second function. This second step.
You as well, Dennis. It should say plot 1 ... on.
Wait, this is like second function step.
I can't hear what you're saying, unfortunately.
I'm trying to
Okay, Madeline, we'll catch up after class. I just want to move on a little bit. I'll take a look at your calculator. Okay. All right. So here, comment on the relationship. So using the terminology in the class, does this look like a linear relationship? So how to turn on stat plot? You went second function stat plot, and where it says plot 1, you hit enter. And you just make sure it says on and that this graph is highlighted. Okay. All right, so going back here. This looks like a somewhat straight line. Absolutely. Okay, does it look like a positive or negative relationship? Yeah, good, you got it. Awesome. Awesome. Yeah. So this looks like a negative linear relationship. Okay, so the next thing it's going to say is to calculate the value of R. All right, the good news is your calculator does this for you, okay? So we're going to hit stat on our calculator. We're going to go over to calc.
Professor,
Yeah.
I am on the line, so where it says where the graph is. So how did you get where you are now?
How did I get, I don't understand your question. How did I get the graph?
Yeah,
Okay, did you input the data?
yeah,
Okay, is your stat plot turned on?
yeah,
Just hit zoom
yeah.
and a zoom stat.
Okay. I got that from here. Where how do you get to where you were before?
I don't get to see what.
Where in the previous where you were showing something like this.
Okay, I'm going next, right? I'm going to calculate the value of R.
Uh-huh.
Okay, so everybody, you're going to hit stat.
Okay.
You're going to scroll over to calc.
Okay.
And the option you're going to use is this, option number 4. Always, 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 lin reg, AX plus B. Okay?
Okay.
You're going to hit enter. If you have a TI-83, you hit enter again. If you have a TI-84, you scroll down to calculate and you hit enter. All right. I'm going to mute it. All right. Does everybody see this on, how many people see this on their screen? If you have a TI-83, just hit enter again. Just TI-83, just hit enter. Then you should see this.
I didn't get the R2 or like the R value.
Because your diagnostics is not on. So you have to hit second function, catalog, and you have to scroll down. Do you see diagnostics on? You just have to make sure that's on.
Okay.
That's the. Okay, so if you look here, the R is negative 0.9701. Okay. I just want to see one thing in the slides real quick. I just want to copy this table. Okay, so if you look here, okay, this value is close, really, really close to -1. Okay, so right off the bat, that tells us, yeah, you know what, there's probably a negative linear relationship. But what if instead it was like 0.7, 0.6? Like, how do you know that it's close enough to either -1 or 1 to signify that there's a relationship? So last class, I introduced this thing called the critical values for the correlation coefficient. So these are what are considered cutoff values. So n is the sample size. Okay, so if you look back here, we have 1, 2, 3, 4, 5 values. So you take the absolute value of this. So since the absolute value of R here is greater than this, we say there is a linear relationship. Okay, for sure. In this case, we can say for sure it's a negative linear relationship. And I will tell you this, on the problem on the exam, it will absolutely say that there's a linear relationship, okay? I will never give you a problem where it fails to be B1, okay?
Professor, can you please repeat that little table again? The table 2?
Yeah. So this was in the slides before, okay? Let me go back. Right here. What you do is you look for n. N is your sample size. There's 5 values, 1, 2, 3, 4, 5. So you scroll over here and this is your cutoff value, okay, 0.878. If I take the absolute value of this, okay, you just if it's negative, just basically you make it positive. Long as this value is greater than this cutoff, you can say yes, for sure there's a linear relationship between the variables. Okay, and on an exam or something, I will give you this table. It'll be in the question.
But you said if it's greater than the value we got, right?
Yes. So this is the cutoff value right here. Yes. To answer your question, Pablo, yes. This is the cutoff value. Do you notice how this is greater than this number? 0.9701 is greater than 0.878.
But isn't that negative?
I said take the absolute value, always.
Okay.
Always. Okay, let's move on a little bit. So next it says find the least squares regression.
I'm sorry, Professor, to cut you. So when you mean absolute value, you mean like taking away the negative sign?
Yes, yep. So an absolute value tells the distance from 1 or distance from 0 of a number. So an absolute value, if it's negative, you just make it positive.
Okay.
Okay. And you can turn off your video, whoever turned it on. Okay. So let's go back. Next question says, find the least squares regression line. So if you remember what I showed you how to do was how to do it by hand, okay? And that sounds awful, okay? So the least squares regression line is this. It's y hat is equal to, I'm going to show you how to use your calculator for this. It's just ax plus b. Previously, I called it b1 and b0. All right. But the reason I put ax plus b here is your calculator writes it that way. So go back to your calculator now. And you should see this, okay? Do you see right here it says, well, a is equal to negative 0.72 and b is equal to 116.6 right here? Everybody see that on their calculator? Okay, that's right there. It's telling you the slope and it's telling you the intercept right there. All right, so going back, the slope is a in front of the x, it's negative 0.72, and the intercept is 116.6. Perfect. It's so much easier doing it this way instead of by hand. So it's negative 0.72 times x plus 116.6. All right, just so we're clear, y hat here, what we're estimating is the max dive time of an individual. And what does x represent again for this example? So x represents, yep, thank you, the depth. So what this is saying is if you give me the depth, x, I can tell you the max dive time of the individual. Okay, that's what we're seeing here. Okay, so next question says, what is this? Interpret the slope. Okay, so what is the slope of this equation here? think it's negative 0.72. Yep, it's right here. Okay, so remember this slope is the rate of change. Okay, so what this is saying is when you increase x by 1, y goes down 0.72 units. Okay, that's what the negative means, it goes down. So putting this in terms of the problem, for each additional 1 foot of depth, max dive time decreases. Okay, the decreases tells me it's negative 0.72 minutes. Okay, that's what the slope is telling us. It's telling us the rate of change. So if you want to go 1 additional foot down, you lose 0.72 minutes. That's what this is saying. The next question says, is it reasonable to interpret the intercept here? Okay, is it reasonable to interpret the intercept? So remember, there were 2 questions you have to ask yourself, okay? Does the model make sense? For x is equal to 0, and 2, are there values close to x is equal to 0? So if you look back at our data for x, are there any numbers that are close to 0? Yeah, no, absolutely not, nope. So there's none here. And also, if you plug 0 in, does the model make sense? Meaning, if I go diving at a depth of 0 feet for x, so if I'm at 0 feet underwater, my max dive time is 116.6 minutes. That doesn't make any sense. No one's going to go diving 0 feet underwater. So no. So the answer to both these questions was no. So it is not reasonable to interpret the intercept. Okay. Before I go on to the next questions, just so you can see that the model fits the data well, just for a little bit of extra practice here, what I'm going to do is I'm going to plug the graph into my calculator just so you could see. So I'm going to hit the y equals button. And I want to plug my regression equation that I got right here into the model. So it was y is equal to negative 0.72 times this button right here. This is the variable button. Plus 116.6. If you look at this, and now you hit the graph button, you can see that this model that we found fits the data really well. Okay, so we can use this now to make predictions. All right, is everybody at least with me at finding the least squares regression line? Is everybody able to do that okay? So to plug this in here, you had to hit y equals, and then you just plug this in, this equation you just found, and then you hit graph, okay? Let me just say one thing. Don't stress so much if you can't get exactly like the visuals, okay? Because I'm not gonna ask you to do any visuals on the exam. Like the big thing here is calculating or finding the regression line equation. Those are the big things to be able to have your calculator do, okay? Now let's look at these 2 questions here, okay? So the next question says, estimate the max dive time at a depth of 55 feet. So this was my equation. Okay. So what am I going to do here? How could I use my regression equation? All right, plug what in? For what variable? Yeah, you're given the depth, which was the x variable of 55. So you're going to literally plug this into your equation. So it's y hat is equal to negative 0.72 times 55 plus 116.6. Can anybody tell me what they got when they plugged this into their calculator?
$77.
Yeah, yeah. So your max dive time at 55 feet is 77 minutes. So max dive time at a depth of 55 feet is 77 minutes. Okay. Now here's the next question. All right. What is the max depth? So now I'm asking you max.
Professor, how did you get 77?
You just plug this in your calculator, right? You go, you plug 55 in for x. So it's negative 0.72 times 55 plus 116.6. That's where that 77 comes from.
Thank you.
Yep. Yep. Okay. At what max depth could you dive for 60 minutes? Hold on here. You got to be careful about this next one. Okay.
Got to plug in 60 where y is.
That's correct. Yeah. I'm asking. Yep, you're right. For depth here. So I'm asking for x. So asking to solve for x. So to do that, I have to give you y, and I do. I give you the dive time of 60 minutes. So you're going to plug 60 in for y. So my y hat here is going to get replaced by 60. And you just have to solve this linear equation here. Okay? So 60 for y hat. So the first thing you're going to do is you're going to subtract 116.6 from each side. These are gone. I think you get minus 56.6. Like this. Then divide each side by negative 0.72, like that. A negative divided by a negative will become a
Positive.
yeah. And if you plug this into your calculator, I think you get x is equal to
38.611.
Yep.
Goes on forever.
Yep, repeating. Usually you just get that. Yep. So the max depth for 60 minutes of dive time would be 78.61 feet. I'm hesitant to ask, but not too bad, bad. Great. It's fine. Okay. All right, let's just do, all right, we're gonna skip our break today. We're not gonna take a break today. I hope that's okay with everybody, but we might end just a little early then. Okay, not okay. So we wanna take a break, is that what we're saying? Everyone needs a break? Okay. You know what? I'm going to make an executive decision here. It's not a democracy. We're not going to take a break. We're just going to move on. Okay. Let's just do one last quick example here. Okay, so we can put this to bed. Okay. All right. This is kind of what you'll see on your exam. So just another one of these. Okay. All right, so whenever you have data in your calculator, let's just clear everything out, okay? So I'm gonna go to my Y equals button here. If you plug this in, I'm gonna clear it out. I'm gonna go to my stat. I'm gonna scroll over to I'm getting ahead of myself. I'm gonna go to edit, number 1, and I'm gonna clear everything out, okay? Just clear everything out. All right. So now to go back to this. So you have this table of data here, okay? And it looks like I have 2 variables here. I have the number of absences and the student's final grade. Okay, so just imagine that I took this data, okay? And I asked, I looked back at students at the end of the semester. I said, how many absences did you have? What is your final grade? So the first thing you need to do is you need to figure out what the explanatory variable is and what the response variable is, y. Okay, so which one do you think is the explanatory variable here? Does final grade explain the number of absences, or does the number of absences explain a final grade? I agree, yeah. Okay, so my x here is the number of absences. And that means my response variable y is going to be the final grade. And I'm going to give everyone who's still listening to me a tip, okay? On your exam, I am not creative. So the first column is always going to be your x variable, and the second column is always going to be your y. So if you're unsure on the first exam, okay, I just gave you the hint, okay? So the first column is always going to end up being your x's, and the second column will always be your y's, okay? Usually most people say thanks for that tip, but that's cool. I understand. I took away the break. No, it's a little too late. It was a forced thanks. All right, so next question says, create the scatter plot, comment on the relationship, okay? So we're gonna have to input the data into our calculator, right? So you're gonna hit the stat button. You're gonna scroll over to calc. Oh my gosh. Forgive me, I always get ahead of myself. You got to input the data. So under edit number 1, you're going to edit the list. I'm sorry. L1 always gets the X variable. So just input the data in the order that it's given. Okay. Don't bother putting it in any ascending or descending order. Okay. Just put it into the order that it's given, like this. And then under L2 gets the Y. So you're just going to put the final grades, 60, 50, yikes, 90, 100, 70, and then 80, and then 92. Okay, so here's the deal. This data here, right, or excuse me, your graphing calculator is zoomed to the previous settings, okay? So you have to rezoom it to this setting. So you're gonna hit zoom, you hit the zoom button. And then what option do you always press? Yep, you got a zoom stat. And how many people see this on their calculator?
Mine has a line. I have the scatter plot, but there's a line passing through it.
Yep, so what you have to do is you have to go to Y equals and clear out the previous problem. Okay, you probably have a line from the previous example in there. Okay. All right, but if you see this right here, just keep with the scatter plot. How would you describe this relationship using the terminology from our class? Negative what? I agree it's a negative. Yeah, looks, it's not a perfect straight line, okay, but it's negative linear, right? Okay, next, let's calculate the value of R, which is the linear correlation coefficient. So the good news is your calculator does this for you, all right, very, very easily. So you're just gonna hit the stat button. You're gonna scroll over now to calc. And what option is it? Yeah, you want this linreg option, thank you. So I'm gonna scroll down to calc. Yep, and you have to be very, very careful here, yeah. The value of R is negative 0.994, I'll round it to 8. All right, so just go back.
Professor,
I'm listening.
mine calculator, right? I can't get the R.
So you have your diagnostics off then.
Oh, okay.
I've talked about it. This is the last time I'll do it, okay? So you have to go to your catalog option here.
Mm-hmm.
Press the X inverse.
Mm-hmm.
Scroll down
Okay.
until you see diagnostics on.
Yep.
There you go.
Okay, I got it.
Now when you go back, you'll see it. Okay. All right, so just so you can see how to use this table again, okay? There are 1, 2, 3, 4, 5, 6, 7 values here. So you go to the table till you see 7. The cutoff value, or the critical value as it's called, is equal to 0.754. If you take the absolute value of this, is it greater than the cutoff critical value? Yeah. So yes, we can say for sure there is a linear relationship here. Okay. Next, it says find the least squares regression line. The good news is your calculator does this for you right here. Okay. So let's just round this to 2 decimal places, okay? So the slope there is the value of A, which is 3.87, and B, that is the Y-intercept, and that's gonna be the value 0.46 when I round it, 98.46, okay? So right there, boom, the calculator gives it to you. That's like fantastic. So y hat is equal to minus 3.87 times x plus 98.46. All right, just so we're clear, okay? X here is the number of absences. What is my y hat here?
Is that the final grade?
Yeah, it's your predicted or your estimated final grade. So if you give me the number of absences, I'll estimate your final grade for you. All right, so let's predict a final grade for 4 absences. Okay, so am I giving you X or Y here? I'm giving you X, I'm giving you the number of absences, yeah. So all you're gonna do is you're gonna plug it in. So the estimated final grade, Y hat, is equal to minus 3.87 times 4 plus 98.46. Now, unfortunately, I didn't work this out ahead of time, so I'm just going to grab my calculator. And I think you get a grade of 82.98. Is that correct? Anybody else get that? Oh, thank you. Yes, appreciate that. So what I'm saying here is, look, if you're going to miss 4 classes, I estimate your grade to be an 82.98. Okay, so roughly an 83. All right, let's estimate the number of absences for a final grade of 87. Okay, so for this one here, what are you given? Are you given X or Y?
Y.
Yep. So now you're going to take this and plug it in. So instead of for X, you're going to put 87 for Y is equal to minus 3.87 times X plus 98.46. So you just have to solve this linear equation. So subtract this over. You get minus 11.46 is equal to minus 3.87x. Divide by negative 3.87. And you get X is equal to what? I think 2.96. So I'm just going to round this to be 3. What do you think? Now that I've done 3 examples here, do you think you'll be able to handle one of these? Yeah, I agree. It just takes a couple practice problems, you know, to figure out what's going on here, okay? It's like my wife always says. She has to tell me 3 times, and then I get it. Can we go over questions from the? Yes. Yep. Can I? Let me just close out of this. Okay. Let me just save this real quick. Yep, now let me talk about the exam now, okay? All right, so I will take homework questions last. Let me just talk about the questions you're gonna get on your exam, okay? So that there's no, nothing out of left field for you, okay? All right, so here are the questions you're gonna get, okay? You're gonna get the following questions on your first exam, okay? So let me just kind of go through each of these in a little bit of detail for you, all right? Definitions and symbols, okay? You know, a question, this is just to help you, okay? A question I always gonna ask is like, what's the difference between a parameter and a statistic? Okay. I don't know, I forgot. Does anybody know what a parameter is? Does anybody remember what a statistic is? And that's not true, I remember, but you know, so you might have to go back and look in your notes for that, okay? Question I always ask is stuff like this. What are these symbols? If I ask you, what does X bar mean in our class? Now here's the thing. If you put the mean, you'll get the question wrong. I'll get to your question in a second. You have to be very specific. This is a sample mean. If I ask you, what does this Greek letter mu mean? Okay, this is a population mean. Okay, you have to be that specific when I get to these symbols. To answer your question, I have no idea if it works on an iPad. I would assume, but I always recommend that you take the exam using Chrome and with a computer. But if you can only take it on an iPad and there's an issue, we can work that out after. Okay. Next, also in here are different types of data types. Okay, like, first thing we talked about was qualitative versus quantitative data. And then quantitative data could be discrete or continuous data. Okay. Those are the next type of, I'll say like somebody's eye color. Okay. Is that a qualitative or a quantitative variable, your eye color?
Qualitative.
Yeah, if it's a category you fit into, right? Like I belong to the category of people who have brown eyes. Like that's just it. Next, there'll be a frequency question related to bar charts and histograms. And what this question is going to be, it's going to be about reading histograms. Okay, I have a question next on the next slide that we'll work through on this. Then there'll be a question on descriptive statistics. This is like given a data set, find the mean, mode, median, range, variance, and standard deviation. Okay. The good news on this is you can just use your calculator to do this. Okay. Then there'll be a question about weighted mean. Okay. We did 2 examples in class, I think, plus we did, you have one on your homework. I would review the GPA and the life expectancy examples from class. Okay, I would review those. There's going to be a quartiles and outlier. The good thing about the quartiles, Q1, Q2, remember Q2 is the median, Q3, your calculator gives you. Okay, but you're going to have to do the test in class for outliers. Okay, you get a chance to practice this on your homework, all right? There's one z-score question, so just remember the z-score is the variable minus the mean divided by the standard deviation. Okay, which is x minus mu divided by sigma. So I think we did an example where we looked at 2 teachers' incomes, and then we looked at exam scores, and then you have a question on your homework about that. And then there's a question, just what we did in class today, in the last 2 days. This correlation and regression. Okay. So I know it seems like a lot, but for a lot of this, you'll rely very heavily on your calculator. Okay, so I do have a couple questions picked out that I'll do real quick in the next 10 minutes or so. But does anybody have any questions about someone said something about the first homework? I did post the solutions for it. If you go to the homeworks, you can see homework number 1 solutions are there. So you can see that I worked through it all for you.
Professor?
Yeah.
Just a simple calculator question.
Sure.
in relation to the sample variance, which
Yeah, I'll show you how to do a problem because the calculator doesn't explicitly give it to you,
okay.
but you can find it. Okay. Yes, the test is Tuesday. Yep. Yep.
Question. I don't know if you already answered this,
I'm listening.
but if I send you my homework number 2, by
Yeah,
the
I'll look
weekend,
it
you'll
over.
do it? Okay,
Yeah.
cool.
Yeah.
Thank you.
Yep. I check my work email every day. The only day I'm not going to check my work email is Sunday this weekend. So if you send it to me, you'll get a response from me within a couple hours, any other day of the week.
Okay, cool. Thank you.
Yeah. It's football Sunday.
Professor, I have a question.
Yeah.
What is the LE example again?
Life
This is
expectancy.
Okay. All right. It's that chart, right?
Yeah. So if you remember, I did the life expectancy of those countries in Northern Africa.
Yeah, I remember.
Okay.
Thank you.
Yeah, no problem. So I'm going to do 2 quick examples for you. One, just a real quick histogram example, and then I'll show you how to do your calculator stuff again in case you forgot, and then we'll call it quits for today. But before I do that, does anybody have any final questions? I'm doing great. Thanks for asking, everybody. Breaking my heart a little. All right. Just look at this one, okay? And just pay attention to this, okay? To how I do this problem, okay? So suppose I give you on the exam just a histogram that looks like this, okay? And what it lists is the amount of time per week that a group of people spend watching TV. So you're gonna have to notice is that along the top here is the frequency or counts, okay? And along the bottom here is how many hours, okay? So this is the group that's between 10 and 15. Here's between, I watch 15 and 20 hours a week. Here's between 20 and 25, and so on, okay? So the problem just asks this: what percentage of people watch between 20 and 25 hours a week? All right, so between 20 and 25 hours a week is this green bar here, okay? So how many people in this chart here watch between 20 and 25 hours per week? What does it look like? Okay. But that's not what the problem asked, right? The problem said, what percentage of people? Okay, yeah, that's right there. So the next thing you have to figure out is the total number. Okay, how can you figure out the total number of people? So this is 30 people. Can you, from this histogram, figure out the total number of people in it? Yeah, that's exactly it. Yeah, so this blue one here, that's 20 people. This red one here is 25 people. This purple one here is 15 people. This like teal one here is 10 people. And this orange one here is 5 people. So if you add this up, 20, 45, 75, 90, yep, thank you. So then just to figure out the percentage, it is absolutely right with the formula. We take 30 divided by 105. As a decimal, you would get, I gotta grab my phone, figure this out. You get 0.2857. So then changing it to a percentage, it's 28.57%. Okay. So do you think you could handle a question, something just like this on the exam? All right. I hope so. I think you guys can. I get good vibes. All right. Let me just do a quick descriptive statistics review. Where did I get the 28? If you plug 30 divided by 105 into your calculator, you get 0.2857. And I just changed it to a percentage. Okay. All right, so here's the last question real quick. So just suppose you have this data set, okay? And it's just a bunch of numbers, okay? 5, 7, 20, 35, 36, 40, 42, 50, 51, 60, 62, and 70, okay? Just these numbers right here. Let's find the following: mean, median, range, and let's just say this is a sample set of data. The variance, the standard deviation, quartile 1, quartile 2, quartile 3, the IQR, and then finally test for any outliers. Okay, I don't even know if there are going to be any, but let's just test for any, okay? All right, so the good news is your calculator does like 80% of this work for you, all right? So I'm going to take my quick calculator right here. And what I have to do is I have to take this data and plug it into my calculator, okay? So I'm going to go press my stat button. Under number 1, I want to edit the list. I'm just going to clear out both lists, but you don't have to. You can just clear out L1, and you're going to put the data in 5, 7, 20, 35, 36, 40, 42, 50, 51, 60, 62, and 70, okay? Now the option that your calculator will do all this work for you, you're gonna press the stat button, and under calc, option number 1, this 1 var stats, produces like all of this for you, almost. So I'm gonna hit enter. I'm gonna scroll down to calc, calculate, or if you have a TI-83, you can just hit enter again. All right, so look here, X bar, that's the mean. Okay, so it's 39.83 right there, boom. Next, you see this S sub X right here just going down? That 20.81, that's the standard deviation. Okay, standard S sub X is the sample standard deviation. The median here, you have to scroll down here and it says median, which is 41. And then the next thing it gives you is these quartiles. Okay, Q1 here is 27.5. Quartile 2 is the same thing as the median, which is 41. And quartile 3 is 55.5. All right, notice it doesn't tell you the range, variance, or the IQR, okay? Does anybody remember the formula for the range?
Isn't it the highest number minus the lowest number?
Yep, it's just 70 minus 5. The range of this data is 65. Now here's the thing. Question is gonna say, well, what's the variance? Okay, so if you remember, okay, the formula for the standard deviation is the standard deviation is the square root of the variance. So the square of the standard deviation would be the what? Yes, thank you. Yeah, so to figure out the variance, all you have to do is square the standard deviation. So you just take 20.87 squared. I don't know what that gets me, 400 something. 433, I'll just round it. Yep, thank you. Does anybody remember the formula for the IQR?
Q3 minus Q1.
Yep, so you would just take 55.5 minus 27.5. And oh my God, I'm so bad at math. Can anybody help me out with that real quick? I'm lazy, I don't want to turn my, thank you. So then the next thing you want to look at is test for outliers. Like maybe this 5 is a low value, I don't know. But you have to test for both upper and lower outliers. So you have a lower cutoff value for a lower limit, which was Q1 minus 1.5 times the IQR, which is 27.5 minus 1.5 times this 28 that you just found. If you plug that into your calculator, can somebody help me out with that? I got it. You get minus 14.5. Thank you. Is there any value lower than minus 14.5? No, so there's no lower outlier. And then you can find the upper cutoff, which is Q3 plus 1.5 times the IQR, which is 55.5 plus 1.5 times 28. You get 97.5. There's no value above it, so this has no outliers, and that's okay, you can have that. All right, I think you guys will do great. I'll stop the recording now and stick around if anybody has any final questions.